All right, seventh grade math. Most of you probably had this last year, so hopefully this is a review. But probability is on there. 10 questions on probability, half of them, five of them on theoretical, and the other half on experimental. So, what is the difference between theoretical and experimental? Well, let's just start off simple flipping a coin. Everybody knows that when you flip a coin, you have a 50-50 chance of heads or tails, which is 1 over 2. We usually write probability as fractions, but not always. Sometimes you'll see it as a percentage or a decimal. But to get a percentage or a decimal, you just divide the bottom number into the top. You convert your fraction into a decimal to get the answer you need. So this would be 1/2 or 0.5 or 50%. You could see it any one of those three ways. 2 goes into 1, 0 times 0.5. Do you need me to show you this? I hope not. It doesn't go into there, so it goes in 0.5 times. How do you turn 0.5 into a percentage? You move the decimal twice. 0.5 becomes 50%. All right, yeah, good. Okay, that's theoretical probability, and that's what you think of when you think of probabilities. You think of theoretical probability. Experimental probability is the one that's a little bit weird that you don't normally think of when you think of probability. And if you're just thinking about flipping a coin, there is no experimental probability. There's no answer to this right now. Because experimental probability means that you have to have run an experiment. You have to have data. And you just look at the results of the data. Right now, we haven't flipped any coins, so there's nothing here. So there is no experimental probability. So I'm just going to make one up. Let's say I get a coin out of my pocket, which I can't do right now because I don't have one in there. But let's say I had a coin in there and I flip it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. I just flipped that coin 10 times. See that? All right, and out of those 10 flips, 7 of them were tails and 3 of them were heads. Now we can make some experimental probabilities. Now we have some data. Now we have some results. And you could ask basically one of two things. What's the experimental probability of flipping a tails, and what's the experimental probability of flipping a heads? The P stands for probability, and then whatever is in the parentheses is what you're being asked to find the probability of. So probability of tails, probability of heads. And you just have to look at the data. These answers aren't necessarily 1/2 and 1/2 like they are over here. That would be the theoretical probability. In theory, you would think if I flipped a coin 10 times, 5 would be heads and 5 would be tails. But it doesn't always work out that way. In this case, it didn't work out that way. 7 of them were tails, 3 were heads. So the experimental probability in this case was 7 out of 10 for tails and 3 out of 10 for heads. So that's the difference between experimental and theoretical. Theory is just imagining, okay, if I roll this dice, what's the chances of it coming up a 3? It's a 1 out of 6. Because with a dice, how many total sides are there? 6. How many of those sides are a 3? 1. So any given number on a dice, you have a 1 out of 6 chance of rolling. Because there's 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Any number would be 1 out of 6. 6 total numbers, 1 of each number. The experimental probability is I'd actually have to roll that dice. And if I rolled it 10 times and 2 of them came up a 3, then the probability of rolling a 3 would be 2 out of 10, which reduces to 1 out of 5. So rarely does the experimental probability and the theoretical probability match up. They usually just don't match up. And that's okay. So don't freak out or get confused if your experimental probability ends up being something that doesn't make sense to you. Because if it doesn't make sense, that means you're thinking of it in theoretical terms. But don't do that. You just have to take the data that's in front of you and fill in the blanks. How many rolls did you have? 10. How many of them were 3s? 2. That's your experimental probability. All right, now this gets taken one step further into predicting the future. Now that you know probabilities, you can become a magician and predict the future. So let's just go back to the same numbers. In our experimental probability, we rolled 10 times or flipped 10 times and we had 7 tails and we had 3 heads. Now, we're going to use this as a model of what's going to happen in the future. So we're going to say that for every 10 times we flip this coin, 7 of them are going to be tails, 3 of them are going to be heads. So let's say we flip that coin 50 times, 50 flips. Now it's not so much of a probability. It might be. It might say, what's the probability of getting tails? Not really. It'll say, how many? When you see how many, that's like a predicting the future magician question here. So now we're magicians. We're predicting the future. How many tails? So if you flip this 50 times, how many tails would you expect to get? And a lot of people are going to say 25. That would be the correct answer on this column. If it's theoretical, yeah, in theory, you got a 50-50 chance of getting tails. So if you flip it 50 times, you should get 25 tails and you should get 25 heads. But we're not asking the theoretical probability question here. This is in the experimental probability column. So with this experiment only, forget about the theoretical. How many times would you expect to get tails out of 50 flips? Well, every 10 flips we got 7, and we just did 5 sets of 10. So 5 times 7, that'd be 35 tails. How many heads would you expect to get? Well, out of every 10 flips we got 3, and we just did 5 sets of 10. So that'd be 3 for each 10. 3, 6, 9, 12, 15. 3 times 5, 15. So 35 tails, 15 heads. That's a total of 50 flips, and that's what we can expect if this experiment, if this pattern holds true over the next 50 flips. Now, it most likely won't, because how things usually work with probability is the more you do things, the more the experiment matches the theoretical. So I could flip a coin 3 times and they all come up heads. My experimental probability would be 100% of the time it's going to come up heads. That's never going to hold true. Eventually, a tails is going to come up. And the more you flip, the closer your percentages will get to the theoretical. So if I were to flip a coin 1,000 times, it's virtually impossible that 700 of them would be tails and 30 of them would be heads. It'd be much closer to 500 and 500. Might not be exactly 500 and 500 like the theory would say, but it's going to be real close. If I were to flip it 1,000,000 times, I'm going to be at like 50.1% and 49.9%. It's going to be almost exactly 50-50. All right, the more you do something, the closer the results get to the theoretical results. So that's what you need to take away from this is experimental, you have to have a set of data, and you just use that data. Theoretical, forget about the data. It's just, in theory, how many with flipping a coin or rolling a dice or spinning a spinner. All right, let me show you the algebra of this. Now that I've explained it, some of you like to use algebra to solve problems. So if you had 7 tails and you had 3 heads, and you wanted to know how many tails, so I'm just doing the same problem here, how many tails on 50 flips. So the same problem we just did, I'm just going to show you the math of it, how you would set this up algebraically. You would say, okay, we're looking at tails. What's my experimental probability of tails? It was 7 out of 10. And 7 out of 10 is equal to how many out of 50? Well, we just figured out it was 35. 7 over 10 is the same thing as 35 over 50, because for every 10 flips we got 7. So 7, 14, 21, 28, 35. 35 we can expect to be tails. But how do you get that just from this math? Well, you set up your experimental probability, that's your one fraction, and your other fraction is how many out of 50, because that's what we're trying to figure out, how many out of 50. And you cross multiply and divide to solve for x. So you cross multiply, 7 times 50 is 350, and that's equal to 10 times x. And then to solve for x, you divide by 10, and 10 goes into 350 35 times. So x is 35. So that's the actual algebra on how to solve these problems, but you probably won't really need that if you just think it through in your head. You know, they're always going to give you a number in your little experiment that goes into the how many times evenly. So if you have 10 flips, they're not going to ask you how many would you predict out of 48. It's going to be how many would you predict out of 50 or 60 or 70, something that 10 goes into evenly, so you can kind of do the math in your head pretty easily. But if you get stuck on the math in your head, that's the actual formula, and you can use that.